The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, I had a request for a couple of questions from section 2B part 1 having to do with unit price. The first question says, find the unit price of a 6-ounce can of beans that sells for 73 cents and write your answer to the nearest tenth of a cent. All right, so we've got 6 ounces for 73 cents. Answer, nearest tenth of a cent. Okay. So a unit price is going to be money per something. So our answer, money per something. Write your answer to the nearest tenth of a cent. So it's going to be cents per ounce. Okay. Because we've got 6-ounce can, that's the weight of it. And the units of money are in cents, and we want it to the nearest tenth of a cent. So we're going to take the money, 73 cents, divided by the units that it weighs, 6 ounces, and we want to take this and change it into so many cents per 1 ounce. Unit price, money on top per 1 of some unit in the denominator. So I'm going to take 73 divided by 6. 6 goes into 7 once. The remainder of 1, bring down the next digit. 6 goes into 13 twice. 13 minus 12 is 1. But I want my answer to the nearest tenth of a cent. And these units are in cents. So this answer here is going to be in cents, but I need it to the nearest tenth of a cent. I need to go 1 decimal place to the right of where I'm going to round. Since I want it to the tenth of a cent, I need to carry out my long division to the 100th of a cent. So we've got our decimal point right here. Okay. And let's get rid of this just because it's in the way at the moment. So I'm going to add a 0, which I'll bring down. 6 times 1 is 6, remainder of 4. I need to go 1 more place, bring it down. 6 goes into 46 times, 36, with a remainder of 4. So now I want to round to the nearest tenth. 1 decimal place to the right is a 6, which rounds up. So it's going to be 12 point, whoops, I guess it can be in red. It doesn't really matter. It's going to be 12.2 cents per ounce. That would be the unit price of the can of beans. Any questions about that particular example? All righty, we've got one more similar situation. Let's see here. This is number 8 from that section. And again, your problem number 7 and 8 will be similar, but may have different numbers. So if you're like, that's not the one I had, but it should be similar. Okay, we're to find the unit price. We've got, let's see, 2.78 pounds of chicken costs $4.83. We want the unit price to the nearest cent. Okay. So unit price, money per something. So it's going to be what? Dollars over what? Pounds. So 1 pound. How much per pound, but rounded to the nearest cent. Okay. So money's on top. 4.83 divided by 2.78 pounds. So we're going to take 4.83 divided by 2.78. Now, I want to point out something. Let's go back for a minute. Yesterday, we did something like this. Well, we'll divide the bottom by 2.78 and the top by 2.78. That'll give us 1 pound on the bottom. So we're really just kind of shortcutting that process by doing the following, by saying, okay, if we divide the bottom by 2.78, we're going to get 1. So we're going to take the top and divide it by 2.78. Are we okay with that? Any questions there? All right, now, I talked yesterday about how when you're doing long division with decimals, you need to have a whole number outside. So I need to move the outside decimal point 2 places to the right, which means I need to do the same thing on the inside, move it 2 places to the right. So now I have the following: 483 divided by 278. Now my decimal point is here in the answer. Okay, now this is dollars. Okay, my units are going to be dollars. So this unit is going to be dollars. This unit would be what? 10 cents. This unit would be 1 cent. This unit would be 1/10 of a cent. I need to go over to 1/10 of a cent to round to the nearest cent. So why am I going to all this trouble? Well, I'm going to need to go out that far. So I'm going to put those zeros there to remind me how far I need to go. Okay, you still with me? All right, we'll find out. 278 goes into 483 just 1 time. So 278, we're going to subtract. We're going to borrow and carry. 13 minus 8 is 5. 7 minus 7 is 0. 4 minus 2 is 2. We're going to bring down the next 0. 278 goes into 2050. Let's see, 9 times, 8 times, I'm thinking 7 times. Let's find out. Let's see, 278 times 7, 56, carry the 5, 49, 54, carry the 5, 14, 19, 1946. No, that's not the year I was born. It's the year I graduated from college. Right. Come on, Courtney, wake up, wake up. Okay. Borrow, carry. 10 minus 6 is 4. 4 minus 4 is 0. 20 minus 19 is 1. Okay. Bring down the next term, 0. Oh, 1946 doesn't go into 1040. So we're going to put a 0 up here and bring down another 0. 1946 is about 2000. 2000 goes into about 10,000 about 5 times. So I'm going to go with a 5. Let's see here. We've got 278 times 5 is 40, 39. I don't think that's right. Hang on. What have I done here? Oh, you know what? I see what I did. I see what I did. I was trying to use that number. No wonder I was confused. In case you're wondering, why am I doing all this and not using a calculator? The person that requested this said they did it using the calculator, but they wanted to see how you do it longhand. And apparently I've forgotten. Okay, this is not the number we're dealing with. This is the number. So let's see here. I got to back up. All right. 278 into 2050. That's about 300 into 2000, about 7 times. Let's see, 7, 278. That's where we got our, boy, I told you I was tired. So that's where we've got the 7 and the 1946, right? Keeping me honest here. Okay. And borrow and carry, that's a 4, that's a 0, that's a 1. Okay. So now we bring down a 0. 278 goes in, let's see, 3, 7, 6, 7 times. Yeah, it'd go in another seven times, wouldn't it? No, it wouldn't. It's too much. How about 6 times? 5 times? 4. See, 4 up, 3. 24, carry the 2. 21, 22, 23, carry the 2, 8. I'm running out of room here. I hate that when you run out of room. 8, 34, subtract, borrow, 6, 0, 2. So we've got a 2, 0, 6, and then another 0, okay, which lines up with this. Sorry about the room. How many times does 278 go into 2060? Well, 7 times was that, so let's go with the 7, okay? So that's going to give us what, a 1946, which we're going to have a remainder. That's all the further I need to go. Why is that? Because this is what I was looking for. What's that going to do? It's going to round up. So we're going to have $1.74 per pound. I'm going to check my work on my calculator. So 4.83 divided by 2.78 is 1.737, yada, yada, yada. Okay. Anyway, sorry I messed that up at the beginning. Gonna have to wake up here. You okay with that? Okay, we'll assume we are. So now we're going to go on to what is 2B part 2. And today we're going to talk about proportions or proportions. And so let's switch screens. And here it says proportions. A popular television program that focuses on home improvement typically has 7.5 minutes of commercials during the 1-hour program. That is to say, the rate of commercials per program is 7.5 minutes per hour, which would also be what, 7 minutes and 30 seconds. Recently, during a 2-hour special of this program, there were 15 minutes of commercials, or the rate was 15 minutes per 2 hours. These rates are in fact equal and could be written as follows. 7.5 minutes per 1 hour equals 15 minutes per 2 hours. Do you see that they're equivalent? They're equal. An equation of this type that has 2 rates set equal to each other is called a proportion. So here's our definition. A proportion states that 2 ratios or 2 rates are equal. Examples of proportions are as follows. 3:7 as 9:21. 5 sharks is to 12 kittens as 20 sharks is to 48 kittens. $8 per hour is the same, is equal to $40 per 5 hours. Okay, and again, the way to read a proportion like this is to say 3:7 as 9:21. All right, any questions about that? The terms of a proportion are numbered as follows. So you've got 4 terms: first term, second term, third term, fourth term. Okay, reading from left to right, top to bottom, the first term is the 3. The last term is the 21. Those 2 terms are called the extremes, the beginning and the end, the first and the last, the alpha and the omega. The 2 middle terms are called the means. So in this proportion, 3 and 21 are the extremes, 7 and 9 are the means. In the proportion 4/9 equals 2 or 12/27, 4 and 27 are the extremes, 9 and 12 are the means. Okay, now note that, let's take this proportion. 4 times 27 equals 108. 9 times 12 equals 108. In the proportion 4 is to 10, 10 is to 4 is 50 is to 20. 10 and 20 are the extremes, 4 and 50 are the means. Note the fact that 10 times 20 equals 4 times 50. These examples illustrate the following. It's called the fundamental property of proportions. In any proportion, the product of the extremes is equal to the product of the means. In symbolic form, it looks like this. If A is to B as C is to D, then A times D equals B times C. That is the product of the extremes, A and C, is equal to the product of the means, A and D. Sorry, I said A and C. Let me say that again. The product of the extremes, A and D, is equal to the product of the means, B and C. Okay. Again, assuming that B or D are not 0 because we don't divide by 0. Okay, now, having said all of that, let's take a look at this example. It says, determine whether the following equation is a proportion. 8 is to 13 as 32 is to 52. So we're going to find the product of the extremes and the product of the means. So let's switch over to the whiteboard. So the question is 8 times 52 equal to 13 times 32? In other words, is the product of the extremes equal to the product of the means? So let's take 52 times 8, 16, 41. Let's take 32 times 13, 6, 9, 0, 2, 3, 6, 11, 4, 16. So yes, this is a correct proportion because the product of the extremes equals the product of the means. Any questions about that example? Okay, let's take a look at another example. 7 is to 11 as 15 is to 22. So the question is, does 7 times 22 equal 11 times 15? 22 times 7, 14, carry the 1, 15, 154. 155 times 11, 15, 15, 165. So no, not a proportion. Okay, now an easier way of saying the product of the extremes equals the product of the means in a proportion would be to say that the cross products are equal. Okay, so again, let's go back here to this text material. The product of the extremes and the product of the means are also called cross products. So if a proportion is true, its cross products are equal. Okay. All right, give me a minute here. And let's see. Okay, we're going to go back to this screen. And now, let's see here. We have a proportion, but one of the numbers is unknown. So we're going to use the variable x to represent that unknown. So in other words, 7 is to 18. 7 is to 18 as 35 is to what? Is to x. Now, we want to solve this proportion for the unknown variable x. So the first thing we're going to do is set the cross products equal. So 7 times x equals 18 times 35. Now, I want to point out some things. When you're multiplying a number times a variable, such as what we're doing here, we put the number in front of the variable, and in fact, we don't need to imply multiplication. If a number is right up next to a variable, multiplication is implied, all right? So this is the variable, and this number is called the coefficient of the variable, or specifically in this case, the coefficient of x. So x is the unknown. The 7 tells us how many of x we have. So 7 is called the coefficient of the variable. All right. Any questions about that? So now we need to solve for x. We need to isolate the x. We need to get rid of the 7 on the side of the equation that has the x. Well, since 7 is being multiplied by the x, we're going to divide by 7. But whatever I do to one side of the equation, I must also do to the other side of the equation. So on the left side of the equation, the 7's now reduced to 1 over 1. 1 over 1 is 1, and 1 times x is x. It's not the number 1, it's 1x. This is not the number 1, this is 1 calculator, not 1, it's 1 calculator. So this is 1x equals. Now, some of you might be thinking, why didn't I multiply the 18 times 35 to begin with? I could have, but I'm waiting till the end because, for instance, in this case, look what I can do. 35 over 7 reduces to 5 over 1. You see that? Any questions there? So now what have I got? I've got 18 times 5. 18 times 5 is what? 40, 90, okay? So now I've solved the equation. I'm going to check my work. I'm going to take this and put it in the place of x and see if I have a true statement. 7/18 equals 35 over 90. Well, if it does, then the cross product should be equal. So let's see. 7 times 90, does that equal 18 times 35? Well, let's see here, 90 times 7, 0, 3, 630. 35 times 18, 40, 28, 0, 5, 3, 0, 3, 6. It checks, so it's correct. So what were the steps? Hang on just a second. We set the cross products equal to each other. We isolated the variable. We simplified the answer if possible, and then we checked our work. Now I want to go back to the other screen as soon as I can find where my mouse has wandered off to. So here are the 4 steps involved. Okay. Set the cross products equal to each other, isolate the variable, simplify the answer if possible, check your work. And I just wanted to put that up there so that if you don't write it down but later need it, you can always go back and check the video if you want to. Okay, so let's take a look at another problem.
Mr. Mayo,
Yes.
If I saw that problem in the homework, I just want to do 18 times 35 and then divide the answer by 7. Isn't
Yes, yes. Now, and this always comes up, Courtney. You're exactly right. That's what we're doing. The reason that I'm kind of dragging it out and formalizing it more is because we're working on the basics of solving any equation. There are some steps involved here. And so, yes, you're right. It's like, for instance, this problem that's up here, basically you're going to take 12 times 5 divided by -6 equals bingo, bingo, bingo. And you could do that, and I would never know the difference. But you'd know the difference because later, when things get more complicated, they'll be referenced back to, now remember, you've got the coefficient, you're going to divide both sides by it, blah, blah, blah. So I'm trying to get you to have skills that'll help you later. Okay, so that's why. So don't shortcut the process. It may cost you later. Okay, I know. We'll see. Okay. All right. So let's take a look at another example. 7 over -2.4 equals x divided by -6. So step number 1, we're going to set the cross products equal. So -2.4 times x equals 7 times -6. Okay, so set the cross products equal to each other. Any questions there? All right, step number 2, isolate the variable. So we're going to divide both sides by the coefficient of the variable, which is -2.4. And there's what you talked about, Courtney, 7 times -6 divided by -2.4. It's in there, yes. So then this is going to reduce down, and we're going to have x equals. Now, as far as pre-reducing is involved, when there's decimals, I recommend not doing the pre-reducing because it gets tricky as to where the decimal point would be. So I'm going to take this out. Let's see, this is going to be -42 divided by -2.4. Negative divided by negative is positive, right? So my answer is going to be positive, and I've got 42 divided by 2.4. I dropped my negative signs because negative divided by negative is positive. By the way, a lot of you missed negative sign answers, okay, on your problems. So you need to go back. Some of you, maybe nobody here, but somebody may be watching this video later, and multiplying negative times negative is positive, negative times positive is negative, all that stuff. Okay, 2.4 into 42, got to move it over one place, got to move it over one place. Okay, 24 goes into 42 once. Borrow and carry. 12 minus 4 is 8. 3 minus 2 is 1. Bring down a 0. Let's see, 24 goes in 7, 4, 8 times. I think 7 times. That's 28. Carry the 2, 16. So I got 1, 2, and bring down a 0. 24 goes into 120 exactly 5 times. So we get 17.5. All right. So we've simplified the answer. Let's check our work. 7 divided by -2.4 equals 17.5 divided by -6. Well, let me ask you this. What's positive divided by negative? It's negative, right? What's positive divided by negative? It's negative, right? So we know sign-wise, it's correct. Oops. I always forget, and I have the eraser on when I'm supposed to be using the black pencil. 7 times -6 is what? -42? What's 17.5 times 2.4? Well, again, it's going to be negative because it's negative times positive. Okay, 4 times 5 is 20, carry the 2. 4 times 7 is 28, 29, 30, carry the 3. 4 times 1 is 4 plus 3 is 7. Bring down a 0. 2 times 5 is 10, carry the 1. 2 times 7 is 14, plus 1 is 15, carry the 1. 2 times 1 plus 1 is 3. 0, 0, 12, 4. Now, how many decimal places do we move the decimal point on the answer? There's 1, 2 to the right, so 1, 2 to the left. Now, could I have taken 17.5 times 2.4 on my calculator? Absolutely, okay? And again, as I said yesterday, you have any questions about how to do things on the calculator, you ask, we'll go into details, all right? Let's see here. I want to look at another example, and this is x divided by 1.5 equals 1.7 divided by 5/6. So the problem here is we've got what, a mixed number, a proper fraction, and a decimal. It would be nice if they were all in the same form, okay? So I should either change them all into decimals or all into fractions. Well, if we go with decimals, we're going to have a problem. 1.5 is 1.5 as a decimal. That's not a problem. 5/6, however, would give us a repeating decimal, and that's going to be a problem to deal with in the equation. So what I'm going to do instead is I'm going to change everything into fractions. In fact, yeah, fractions, not mixed numbers, not decimals, but fractions. So 1.5 would be 3/2, okay? 1.7 is 1 7/10, which is 17/10. So I'm going to get x over 3/2 equals 17/10 over 5/6. Okay, so I changed everything into fraction form. You okay with that? All right, so now let's set the cross products equal. 5/6x equals 3/2 times 17/10. We okay there? Any questions so far? Now, the next step seems to be getting rid of the 5/6. So let's divide both sides of this equation by the 5/6. Okay. Now, if I do that, on the left side of the equation, the 5/6 and the 5/6 would simplify out, and I'd have x equals. You still with me? On the right side, though, I've got a mess. I've got a fraction times a fraction divided by a fraction. Well, wouldn't dividing by this fraction be the same? Dividing by this fraction, it'd be the same as multiplying by the reciprocal. Okay, you still with me? Well, if dividing by a fraction is the same as multiplying by its reciprocal, there is an easier way. When the coefficient, oh, I need to get rid of this. When the coefficient of the variable is a fraction, rather than divide both sides by that fraction and then on the right side change it to multiplying by its reciprocal, let's go straight to multiplying by its reciprocal. Saves you a step. That's where you're going to end up on the right side anyway. Okay. Now, what's going to happen on the left? In fact, one of the definitions of reciprocals is the product of two reciprocals equals 1. The 6 is reduced down, the 5 is reduced down. 1 times 1 over 1 times 1 is 1 over 1, which is 1. And 1 times x is x. Okay, so when I multiplied both sides by the reciprocal of the coefficient of the variable, and some of you, all you're hearing is blah, 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 all these terms. My head hurts, right? Okay, you'll get there. It's okay. Courtney, don't look so sad. All right.
Not sad, just trying to follow.
Yeah. All right. On the right side of the equation, I'm going to go in and do some pre-reducing. Okay. Let's see. Well, I can do 6 over 2 is 3 over 1. I think that's about it, isn't it? Because I've got 3, 17, and 3 on the top, and 10, which is 5 times 2 times 5 on the bottom. So on top, 3 times 3 is 9 times 17. 17 times 9 is 63. Carry the 6, 153. And then 10 times 5 is 50. So x equals 153 over 50. Now, the question might come up, what form do I leave the answer in? Do I leave it as an improper fraction? Do I change it to a mixed number? Do I convert it to a decimal? Generally, I would say this. Look to the original problem for clues, okay? Let's say that in the original problem, there were just decimals. Then I would go with a decimal answer. Just fractions, I'd go with a fraction answer. Just mixed numbers, I'd go with a mixed answer. But this problem has everything, doesn't it? So any one of those forms should be correct. I could use 153 over 50. Let's see, 153 divided by 50 would be 3 and 3/50. So x could be 3 and 3/50. That would also be correct. Or a decimal, I'm going to grab my calculator right here. 153 divided by 50 is going to be 3.06. So any one of those answers would be correct. Now, there may be instructions in WAMAP that would say, write your answer as a improper fraction or a mixed number or a decimal, in which case you've got to follow the directions. But if it doesn't, then any one of these three would be correct. Okay. Now, in solving these problems, if the coefficient is a whole number or an integer, so like it could be a negative number, or a decimal, divide both sides by the coefficient and continue on. If the coefficient is a fraction, multiply both sides by its reciprocal and carry on. Now, if you forget and you take something like this and you divide by 5/6 and you divide by 5/6, you still get there. You just have extra steps, like the way I started out this problem, okay? But if you can remember, it'll save you some work. When do you multiply by the reciprocal? When the coefficient is a fraction. Okay, I'm going to say it once more. If the coefficient is an integer or a decimal, divide both sides by it. If the coefficient is a fraction, multiply both sides by its reciprocal. That will help you to skip a step. Okay. Now, the next thing we're going to do is we're going to look at some story problems where we're going to read the problem and then translate it into a proportion and then solve the proportion. Okay. So give me a second here. Get to the page I want to be on. Okay. Let's take a look at problem 49 up there at the top. It says, Translate each of the following word problems into a proportion. Then solve the proportion in order to answer the question. Ben goes to the grocery store at a rate of 3 times a week. How many times would he be expected to go to the grocery store in 16 weeks? Now, notice the wordage or the verbiage. It says, how many times would he be expected to? There's an assumption that we're making in all proportions, and that is that whatever's been happening at whatever rate it's been happening will continue to be happening, okay? And that isn't always true, but for the sake of solving a proportion, we make that assumption. All right, we said earlier that a proportion was 2 ratios or 2 rates that were equal to each other. Ben goes to the grocery store at a rate of 3 times per week. So 3 times in 1 week. How many times would he be expected to go to the grocery store in 16 weeks? So X times in 16 weeks. Notice that on both sides of the equal sign, my units for the rates are the same. Times per weeks, times per weeks. Okay, that's
Can you go to
important.
the whiteboard screen?
My bad, thank you. All right, so notice I've got 3 times per week equals X times per 16 weeks. So my units for my rates are the same. Times per week, times per week. I don't have times per week and then weeks per time. That would not work, okay? So we've got to have the units across from each other, the same units, right? Thanks for reminding me, Courtney. I knew I'd forget at some point. So now that it's set up this way, we're going to take the cross products. 3 times 16 equals 1 times X, okay? Well, what is 1 times X? It's just X, right? So I don't need to bother dividing both sides by 1. I can just see that. 3 times 16 is 48. So the question said, how many times would he be expected to go to the grocery store in 16 weeks? So the answer would be 48 times. Are we okay with that? All right. Let's take a look at another problem. Let's see. Let's take a look at let's do number 59. Hopefully I'll remember to switch things over. If a 30-acre alfalfa field produces 180 tons of hay, how many acres would a field need to be in order to produce 288 tons of hay? So we've got, and I'll switch over here in a minute, we've got 30 acres produces 180 tons. Okay, so I'm going to go back to my whiteboard screen. All right, I'll read it again. If a 30-acre alfalfa field produces 180 tons of hay, so I've got 30 acres, 180 tons. How many acres would a field need to be in order to produce 288 tons of hay? Since on the left side, I've got acres per tons, on the right side, I'm going to have acres per tons. That tells me where to put the units. That way I'll be sure to put the numbers in the right place. Okay, so how many acres, so that's the unknown, would a field need to be in order to produce 288 tons of hay? So acres per tons, acres per tons. Now, I could have started out and done it this way. But then if I had, I would do it like that. You understand what I'm saying? They have to be consistent. You can go acres per tons, then acres per tons, or tons per acre, then tons per acre. Okay. You get the same result. So now let's set the cross products equal. 180x equals 30 times 288. Our coefficient is a whole number, so I'm going to divide both sides by that whole number. Now, again, I could have gone ahead and taken 30 times 288 before I divided both sides, but I like to leave it till the next step in case I can pre-reduce some things. Can't always, but in this case I can. Notice this. I could divide the top and the bottom both by a 10. I could divide the top and the bottom both by a 3. That would be a 1, and this would be a 6. So now I need to take 288 divided by 6. And again, if you want to use your calculator, that's just fine. 288 divided by 6 is 48. So the answer, 48 acres. Now, let's talk a minute about units. Pay attention to units. Look at in WAMAP. Do you need to put the units? Are they already included in the answer? Let me give you an example. Somebody asked me, how tall are you? Say, how tall are you, Mr. Mayo? Come on, somebody, please, please. It's not a trick question. Nobody's going to do it.
How tall are you?
How are you, Mr. Mayor?
6. I'm 6.
6 what, Mr.
Thank
Mayor?
you. Thank you, Courtney. I know, 6 feet, right? So in that case, I needed to list the units, or you would think, what, 6 inches, 6 kilometers, $6, okay? But what if I said this? What if you asked this? What if you said, how many feet tall are you, Mr. Mayo? And then I said 6, even though it's still a little awkward, you would know from the question what the units were, right? Okay, my point is this. Pay attention to the units. So for instance, this problem 59, the question said, how many acres would a field need to be? So you could get away with 48 because the question says how many acres. But if it said, how big would the field need to be? You'd have to say 48 acres. And again, in WAMAP, pay attention to the units in the answer. Do you need to include them? Are they already included? Et cetera, et cetera. All right. Okay, so proportions, 2 rates or 2 ratios that are equal. We solve them by setting the cross products equal to each other, isolating the variable, simplifying the answer, checking your work. I will be back again at 1:15 today with an office hour. Otherwise, I will see you tomorrow. I'm going to go ahead and stop the recording